language is the first-generation language. It is the lowest level of programming language understood by computers to perform operations, and they could only solve one problem at a time. It represents data and program instructions as zeros and ones, binary digits corresponding to the on and off electrical states in the computer. This is really the only language the computer truly understands. All other languages must be translated to the machine language before execution. When engineers designed and built the first computers, the only people who could program these computers were the engineers themselves. This was a tedious job, even for the engineers, as the language used to communicate with the computer was in terms of binary signals, that is, machine language. To perform a simple task, such as adding two numbers, the engineer had to enter a series of binary codes. Assembly language. Assembly language is the second-generation language. It is a symbolic language. Engineers have come up with symbolic language, so instead of remembering binary codes, they only had to remember mnemonic, that is, symbolic codes. The machine language was so cryptic that even the engineers faced difficulties remembering the different codes. Assembly language implements a symbolic representation of the numeric machine codes and other constants needed to program a particular CPU architecture, and it allows programmers to specify instructions in words. Assembly language eliminates much of the error-prone and time-consuming first-generation programming needed with the earliest computers, and it frees the programmer from hectic jobs such as remembering numeric codes and calculating addresses. It promotes the use of names for memory locations instead of actual address numbers. For example, A for add, C for compare, MP for multiply, and STO for storing information in memory. The assembly languages were machine-dependent. Thus, a program written on one particular machine could not be executed on another make-of computer. However, a translator, called an assembly program, was required to convert the assembly language program into machine language. Procedural language. Procedural language is the third generation and a high-level language. It is high-level because it is more human language and machine, or assembly languages, that is, people are able to understand. However, most people still require some training to use higher-level languages. But this is true that procedural language are designed to express the logic, the procedures, that can solve general problems. Thus, it is intended to solve general problems. A procedural programming language provides a programmer a means to define precisely each step in the performance of a task. The programmer knows what is to be accomplished and provides through the language step-by-step instructions on how the task is to be done. Using a procedural language, the programmer specifies language statements to perform a sequence of algorithmic steps. Procedural programming is often a better choice than simple sequential or unstructured programming. In many situations which involve moderate complexity or which require significant ease of maintainability. It is a portable language as it can be run on more than one kind of computer, and it has ability to reuse the same code at different places in the program without copying it. However, like assembly languages, procedural languages must be translated into machine language so that the computer processes them. Depending on the language, this translation is performed by either a compiler or an interpreter. A compiler translates the entire program into machine language before executing any of the instructions. On the other hand, an interpreter translates and executes a single instruction or small groups of instructions at a time. A compiler or interpreter is itself a computer program that accepts a high-level program as input data and generates a corresponding machine language program as output. Examples of third-generation languages are COBOL, Common Business, Formula-Oriented Language, was designed to write business programs. Fortran, Formula Translation, was designed for scientists and mathematicians. It is very useful for processing complex formula. Basic, beginner's all-purpose, symbolic instruction codes was designed to allow the layman to write a computer program. It was meant to be as simple as possible. Pascal was developed as a disciplined, high-level language for teaching structured programming. C is a general-purpose, structured language like Pascal. HTML, which stands for Hypertext Markup Language, is not strictly a programming language but consists of statements, or tags, that are saved in document files. Browsers interpret these HTML documents to display web pages. C++ adds support for object-oriented programming. And finally, Java is widely used to enhance animation and other interesting features of web pages. Problem-oriented language. Problem-oriented language is the fourth-generation language, and it is very high-level language requiring little special training on the part of the user. Problem-oriented languages were designed to solve specific problems, such as querying databases, and allowed the programmer to concentrate more on the problem rather than spending time learning the complex syntax of the language. The fourth-generation language is designed to reduce programming effort, the time it takes to develop software, and the cost of software development. However, it is not always successful in this task, sometimes resulting in inelegant and unmaintainable code. But problem-oriented language is used for special applications like querying languages, where it enables users who are not programmers to use certain easily understandable commands to search and generate reports from a database. Application generators, which contain a number of modules which are logically related program statements that have been pre-programmed to accomplish specific tasks. An example would be a module that calculates value-added tax (VAT) on products. Natural and visual programming language. Natural language is the fifth-generation language. The standard definition of a fifth-generation language, 5GL, is a computer language that incorporates the concepts of artificial intelligence to allow direct human communication. Additionally, these languages would enable a computer to learn and to apply new information as people do. Rather than coding by keying in specific commands, we would communicate more directly to a computer using natural languages. As they have evolved through the generations, computer languages have become more human-like. The fifth-generation language refers to using natural languages, such as English, French, or Japanese, to communicate with computers. They aim at providing people with a more natural interface to communicate with computers. Users, therefore, will not require special training for writing programs. Researchers also hope that natural languages will enable a computer to learn to remember information as people do, and to improve upon it. Fifth-GL are programming languages that contain visual tools to help develop the program. A good example of a fifth-generation language is Visual Basic.